Hi, Tamisha. Welcome back. Hopefully you've got your pen and your calculator and everything that you need with you. You can get started on the do now. Let's see who else is here. Hello, Yandi. Hello, Aisha. Hello, Esther. Welcome back. Sorry, I look like I'm sitting in the dark here. I'm not, but just for today, I've got a little bit of a light crisis in my house. So you'll just have to forgive me. I'm sorry. At least the lights are on in your house. Hey, Yandi. Thank goodness for that. Hi, Theo. Hi, Owetu. Hi, Trevor. Hi, Njabulo. Please get started on the do now, and then we'll talk about decimals, percentages, and fractions. Okay, so this leads on from what we were talking about last week, where we were talking about adding and subtracting fractions. Okay, so hopefully everybody can manage these questions without too much difficulty. Okay, so just get started on the do now, grade 7s. And hopefully we can still do the things that we learned about last week. Can't you hear me, Yandi? I don't know, maybe Elzan can help us with that. Can you still not hear me, Yandi?
Yandi, I would propose maybe log off and then try to come back on again, okay? I see that there might be a problem with your audio. There we go.
Is Yandi back?
Yandi, can you hear us?
Okay, so grade 7s, we're just trying the do now questions. We're going to talk about the answers to that, and then we're going to move up the sheet and then move on with our lesson. Okay. I hope everybody can hear me. If you can hear what I'm saying, can you have a thumbs up from you, please? Just to make sure. Yes.
Yeah.
Okay. All right. Thanks, Solzan. Thanks, Pumasile. Cool, Theo. Okay, Anel. Good. I'm glad. Good, Njabulo. Good. Thanks, Olwe, too. I'm glad you can hear me.
Ma'am,
Yes, Trevor.
why is your background so dark? I can't even see.
I know, Trevor. I feel like I'm sitting here in the dark ages. It's all my son's fault. He stole my light and he wouldn't give it back to me. He's naughty, isn't he? So that's
Yeah,
why I
he
feel
is.
like he is very naughty. But unfortunately, he's too big for me to smack him anymore. So, so that's why I'm sitting here like a mushroom in the dark. So, but don't worry,
Yeah.
Trevor, I'm still here. Next time, I'll make sure that my son doesn't steal my light. Okay, but yeah, so I'm sorry about that, Trevor, but yeah, you're just going to have to, unfortunately, live with me sitting in the dark today. It's actually not dark in this room. It just looks like I'm sitting in the dark, even though I'm not. Did you think that was funny in Jabulo? Yes, like a mushroom growing in the dark. Okay, all right, so let's try these questions. All right, so in question number 1, Theo, what did you get as your answer for question number 1?
7/12, ma'am.
I beg your pardon, Theo?
7/12.
You got 7/12. Right. Who also got 7/12 for that one? Can we have some thumbs ups or thumbs downs? I agree, Anel. Nothing wrong. Yes, Pumzile, me too. I think there's absolutely nothing wrong with Theo's answer. Okay, so well done, Theo. That's perfect. Good job, Trevor. Okay, number 2. Olwetu. Can I ask you, what did you get for number 2, Olwetu?
Lay, can I please answer?
Sure, Anel, go for it.
I got 3/10.
3/10. Okay, so I think Olwetu put an answer in here. Olwetu said she got 1/3, or he got 1/3. Let's have a look, right? So what we would have done here is we would have times that by 5, and we would have times that by 5, and then we would have times that by 2, and we would have times that by 2. So quite right. Okay, Anel, you are correct, because we would have ended up with, let me just make a little bit more space here. We would have ended up with 5/10 minus 2/10, which is quite right. We would have ended up with 3/10. Is that okay, or where to? We wouldn't be able to simplify it because 3 doesn't go into 10. Okay, it's almost a third, but it's not exactly a third. Does that help, all where to? Okay. Pumzile, what did you get for question number 3?
Ma'am, can I answer for her?
You go for it, Trevor, no problem.
It's 9/18.
9/18, Trevor says. Okay. I agree with you, Trevor, but there's only one thing that we would need to still do. Can you remember what that is from the last time?
To change it into a mixed fraction.
Okay, so this one, Trevor, you won't be able to make into a mixed fraction because your
We need
numerators.
to simplify it.
We need to simplify it, quite right. All right, so we would say in this situation that 9 goes into itself once and 9 goes into 18 2 times. So our final answer would be 1/2. All right, so just to go through what Trevor, Njabulo says he can't hear anything. And Pumzile says the screen is blurry. Maybe you just need to log off and log on again, both of you. Okay, that's what Alzan suggested for, not for Trevor, for somebody else. Yeah, log off and log back on again. Okay, so the 5/6 is staying the same. We're going to multiply 3 by 2 to get 6. So we must multiply the numerator by 2 as well. And then that means that we end up with 3/6, which is the same as 9/18, which is 1/2. Njabula, if you can't, or maybe you can hear now. Njabula, you said you can't hear anything. Can you hear us now? I'm hoping so. All right. So let's carry on with the last question. I don't know if anybody managed to be able to do this one as well.
Can I please answer it?
Sure, and I'll go for it. What did you get?
I got 13/15.
13/15. Okay, so you went times by 5 here and times by 5 there and times by 3 here and times by 3 here. And that would have left you with 10/15 plus 3/15. Absolutely. Okay, which is 13 out of 15. Good job. Well done. Okay, so hopefully everybody's feeling confident with adding and subtracting. And we can move on and we can talk about the next thing, which is our fractions, decimals, and percentages. All right. So I went online and I had a look and I tried to find some sort of nice, exciting things that we could use to talk about in our lesson today. All right. And fractions, decimals, and percentages are all related to one another. So in other words, we are writing the same value, but just in a different way, all right? So if I say to you, I ate half the cake, right? It would be the same. So if I ate half of a cake, so 1/2, if I ate half of a cake, it would be the same as me eating 50% of a cake, or as me eating 0.5 of a cake. All right, so your 0.5 is where it's written in decimal form. So using, actually it's supposed to be in South Africa, it's supposed to be a decimal comma, not a decimal point like that. A percentage is when a fraction is written out of, does anybody know? Have you worked with percentages before, grade 7s?
I have.
Okay, that's good to hear. Anybody else?
Yes, ma'am.
Okay, Tamisho. Okay, Yandi. So what is the difference between a percentage and a fraction? How is a percentage always written? What's the same thing every single time?
The percentage is a whole number.
Okay, it can be, all right, but what about this one down here? Okay, so that one over there down at the bottom, that's unfortunately not a whole number. So it can be a fraction, right? So let's say you go to school, right? And you write a maths test. If your teacher says to you, you got 10% for your maths test, are you going to be happy or are you going to be sad? Sad, indeed. Okay, but if your teacher says to you, well done, you got 95% for your maths test, are you going to be happy or are you going to be sad?
Happy.
Happy. Exactly, because a percentage is something that we all understand. All right, because a percentage is always out of the same thing. So when your teacher says to you, you got 10% for your maths test, and hopefully we never get 10% for our maths test, our teacher is saying to us, you know 10 out of 100 things. That's what it means. Okay. If our teacher says to us, well done, you're so clever, you got 95% for your maths test, our teacher is telling us, we know 95 out of 100 things. Okay, so that's why we're happy over here, but we're sad over there. Okay, so a percentage means that something is always going to be written out of 100. And in fact, the 100 is there for you. If you have a look, if I write, let me write 75%. Look here, all right? I'm going to take the 7 and I'm going to put it here. I'm going to take this 5 and I'm going to put it over here. Then I'm going to draw my line underneath. This line over here, that's my 1. And then look, I've got 2 zeros. Got a 0 here, which I'm going to write there, and another 0 over here, which I'm going to write there. Okay, so that's a way for you to remember what 75% means. Okay, 75% or any percentage means 75 out of 100. Okay, is everybody happy with that?
Yes, ma'am.
Yes, ma'am.
All right,
Yes, ma'am.
so good stuff. So now when we go from our percentage column to our decimal column, what have we done? Does anybody know? So if I want to go from 50% and I want to get an answer of 0,5, what am I doing? How am I changing the 50% to get this answer on the right-hand side?
Ma'am, can I try?
Of course, Yandi.
I think you say 50 divided by 100.
You do. Good job. Keep going, Yandi.
Oh yeah, ma'am. 50 divided by 100 is gonna give you decimal of 0,5.
It is going to give you 0,5. And the reason why it's going to give you 0,5 is because you can divide by 10 at the top and divide by 10 at the bottom. That gives you 5 out of 10.
10.
Exactly. And we know that when we write our decimal commas, if we've got a value sitting over here and there's our decimal comma, this first column here is called our tenths column. Okay, so 5 means 5 is sitting in the tenths column. Okay, so 0,5 is the same as 5 out of 10. It's just 2 different ways of being able to write the same thing. So quite right, Yandi, when we go from percentages to decimals, we are dividing our number by 100, and then we want to try and simplify using the highest common factor. Okay,
Yes, ma'am.
when we are, yes. Did somebody want to ask something? No, we're all good?
Yes, ma'am.
All right.
Yes, ma'am.
So let's just talk a little bit about what happens if we want to. So if we've been given, because we're just going to be swapping between them. So sometimes they might give us a fraction, sometimes they might give us a decimal, sometimes they might give us the percentage, and then they ask us to work out what the other thing, right? So now how are we going to work out what our fraction is if we know what our decimal is? So for example, if we start with that, so if we've been given 0,25 and they want us to write that as a fraction, well, how are we going to write 0,25 as a fraction, first of all?
So, ma'am, it has to be out of 100. So I'd say the same way to do it is to say 25 out of 100.
Good, well done. That's excellent. Okay, so here your 2 is sitting in the tenths column. Your 5 is sitting in the hundredths column. So that's very, very good. 0,25 means 25 out of 100, right? And now we can simplify it in the same way that we simplified Trevor's 9/18. 25 goes into 100. So what we can do here is we can say 25 goes into itself once, and it goes into 100 4 times. Okay, so we can write that as a quarter. Alternatively, what they could do is that they could say to us, well, if we've got 0,25 and we want to write that as a percentage, we know that it means 25 out of 100. So we would write that as 25%. Is everybody happy with that?
Yes, ma'am.
Yes, ma'am.
Okay.
ma'am.
Yes, ma'am.
Okay,
Yes,
good
ma'am.
job. Okay, so here, let's have a look at this. So this gives us a way of being able to go from one to the other. So when we've got a fraction, we want to divide the numerator by the denominator to get a decimal. And then when we've got a decimal, we want to multiply by 100. In other words, to get a percent. Okay, so now here, what they want you to do is they want you to write these fractions first as decimals and then as percentages. Okay, is there anybody who feels confident to write the first one, 1 out of 2, as a decimal?
Yes, ma'am.
Okay, Stembiso, how would you write it as a decimal?
Me, ma'am.
Yes, Stembiso.
Ma'am, I'll write it as 0.5.
0.5, absolutely. Is there another way that we could write that as a decimal?
Decimal.
What about if I wrote it as 0.50? Would it mean the same thing?
Yeah, it would.
No,
It
ma'am.
would, wouldn't it? Okay, so here, 5 out of 10 is the same as 50 out of 100. And if I decided to do this just because, then it would be the same as if I wrote this as 5 out of,
100.
oh, sorry, I'm talking nonsense here, 500 out of 1,000. Okay, so it would all mean the same thing in this case. Now, when I want it to become a percentage, I need to multiply my decimal by 100. So what happens when we multiply a decimal by 100? What happens with our decimal comma and our numbers?
It moves away.
They do, they move, don't they? So the
Forward.
truth, yes, indeed. Okay, so in other words, where our decimal comma sits, that point is a fixed point. But the numbers can move to the left and the right depending on whether we're making them smaller by dividing or making them bigger by multiplying. So if I take 0.5 and I decide to multiply it by 100, this 5 that was sitting here in the tens column, is it going to move to the right or is it going to move to the left?
To
Left.
the left.
It's going to move to the left. How many places to the left is it going to go?
2
1.
times.
Oh.
Two is right. Okay, so in other words, it's going to move by the same number of zeros that I've got. Okay, so it moves from the tenths column to the units column to the tens column. Okay, so now it's sitting in the tens column. We've got 0 sitting in the units column, and then the rest of these would just be filled up with zeros. And now it's been written as a percentage. Do you want me to do another one like that?
Yes, ma'am.
Yes,
Okay,
ma'am.
no problem. Let's do another one together. Okay, so now we're looking at the fraction 3/4. All right, how are we going to write that? Do you know how to do long division?
Yes, ma'am.
Wow.
Yes, ma'am.
Or does long division make us scared?
No, ma'am.
No, it's not scared. Okay, so if we've got 3 divided by 4, this is really what we're doing. We've got 3 inside and we've got 4 on the outside. Have you seen this at school?
Yes, ma'am.
You've seen this at school. Okay, so this 3 means 3 whole units. What's the problem here? Does 4 go into 3?
No.
No, it doesn't. So what do I need to add to sit next to the 3?
4 or 0.
A 0,
0.
exactly. I need to add a 0. And now what am I asking myself? Does 4 go into
30.
30?
30.
Okay, 4 goes into 30, right? So I'm going to have a 0 over here because it goes in 0 times. How many times does 4 go into 30?
8 times.
8
7
times?
times.
7
7.
times?
Yes.
7 times? 7 times 4
7
is?
times.
8.
28.
28,
28.
absolutely. If it went in 8 times 4 would give us with would give us
32.
32. Yes, correct. So
28.
it goes in 7 times. Okay, so now I have to say 7 times 4, and then I have to subtract 28.
3,
Okay, and that's going to leave me with
2,
2. Okay, and now I've got to
add a 0.
add a
Bring down
0. I've got to bring down and I've got to add a 0. Okay, and now I say to myself, how many times does 4 go into 20? It goes in there
5
5
times.
times.
5 times. Well
times.
done. 5 times 4 leaves me with 20, and then I have
0.
no leftovers. Exactly. Okay, so that's how I'm going to go from my fraction to my decimal. So in other words, 3 divided by 4 or 3 over 4 is the same as 0.75. Okay, now when I want to go here to my percent column, what must I multiply 0.75 by?
Times 100.
Times 100. So written as a percentage, it's going to be
75%.
75%. Quite right, Boy J. Perfect. Okay, so now I would like you guys to try and do one on your own. Okay, so let's see what happens with 2.5, which I'm putting a star next to. And if you finish that, then you can try 1.8, but I'd like everybody to at least do 2 over 5, and then we can maybe have a look at some of the others. And if you've got a question, then ask me. All right, so I'm going to give you 3 minutes to try that. Okay, grade 7s?
Lay,
Yes. Yes,
I did
Anel?
my I do my working out of my decimals differently.
Okay, that's fine. How do you do it, Anel?
So I see how many times 5 can go into 100, then I times the numerator and the denominator by 20, and then I get 40 over 100.
Absolutely. Nothing wrong with that, Anel. Perfectly acceptable way of doing it. So that's 100%. Another way that you can do it with all of these. So when you're working with this, that's not going to go into, well, mind you, it would go into 10. It would go into 100. Over here, 8 is not going to go into 10. It's not going to go into 100. You would have to use.
It's going to go into 1,000.
Into 1,000. Absolutely nothing wrong with your method at all. All right, perfectly acceptable way to do it. Okay, so a lot of you are saying that you are done. Good job. Okay, so
And can I try?
of course, Yandi, I was going to ask you, what did you write 2 over 5 as a decimal?
0.4.
0.4. Okay, who agrees with Yandi?
She's correct.
She is, isn't she? She's done that perfectly. And then how would we write that as a percentage, Yandi?
Then in my decimal, I will say 0.4 multiplied with 100. Then the total mark for my percentage is 40%.
Good, well done. That's excellent. Good job. Well done, Yandi. Very nice.
Thank you,
Okay.
ma'am.
Good job. Okay, so now, Boy J, did you manage to do 1 over 8?
Ma'am, not yet, ma'am.
Not yet. Okay. Who's done 1 over 8?
Me, ma'am.
Me, ma'am.
Okay. All right, Theo, I'm going to give you a chance to talk. Okay, what did you get, Theo?
12.5%, ma'am.
12.5% over here. Okay, and then what did you get as a decimal?
12,5.
Okay, but you mean 0,125. Is that what you mean, Theo?
Yes, ma'am.
Okay, all right. So some of us are feeling, I think, very confident with this and we know exactly how to do it. And maybe there are some other people that are still feeling as though this is a bit difficult. I'd like to give you an opportunity to practice at least another one of these. Is there anybody who would like to me to help them with 7/8, writing that as a decimal, or perhaps 1/8 if you didn't understand it?
Yes, ma'am.
Is that okay
Yes,
if we do
ma'am.
that? Okay, all right. Now, so the rest of you, you can do as many as you can by yourself, and we'll talk about the answers now. And then I'm just going to help Tamisha and whoever else said that they needed a little bit of assistance. Okay, so just ignore what I'm saying and you carry on doing your own work. Okay, so I don't know what suits you better, Tamisha. I can't remember who else said that they needed help. Do you do long division, or do you prefer to do what Anel was saying, and that's to make the denominators, to change the denominators? Which method do you prefer doing?
Ma'am, long division.
You like doing long division. Okay, Tamisha, then let's do long division.
Ma'am?
Yes, Njabulo?
Ma'am, which one is better between long division or changing the
Or changing the denominator?
Yes, ma'am.
Njabulo, I think that if you change the denominator, I think that's a little bit faster. But I don't think you're going to get any less marks. So I think that method will be a little bit quicker for you. Okay, so maybe that's the one that you want to try. Okay, so Tamisha, let's do long division, and then we'll also talk about changing the denominator quickly. All right. In fact, let's change the denominator first. All right. So essentially, what we're doing in Njabulo is we've got 7/8, and we are creating an equivalent fraction, and it has to either be out of 10 or 100 or 1,000 or 10,000 because of our decimals. Okay, so our tenths column, hundredths column, thousandths column. So 8 doesn't go into 10 a whole number of times. 8 also doesn't go into 100 a whole number of times. So when we've got 8 as a denominator, we have to use 1,000. Okay, so this is something that you can learn, right? If we take 1,000 and we divide it by 8, we get 125. So we're going to have to do the same thing at the bottom as at the top. So here at the top, we're going to have to multiply 7 by 125. So before you can get your answer over here, you're going to say 125 times by 7. I don't know if they let you use a calculator or not, but if they don't, you'd have to do this. So you say 7 times 5 is 35. Put down the 5, carry the 3. 7 times 2 is 14. 14 plus 3 is 17. Carry the 1. 7 times 1 is 7 plus 1 leaves me with 8. So that would be 875 out of 1,000, which means that if I write that as a decimal, it will be 0,87. Whoopsie daisy, let me just move this out the way. 0,87. 5. Okay, now Tamisha, if we do it the other way, where we do long division, let's do that on the side over here.
Yes, ma'am. It's easier, ma'am.
Do you think this is easier, Tamisha?
Yes, ma'am.
Okay, are you happy to do it
Yes,
this way, or
ma'am.
do you want me to do the long division as well? Because I don't mind.
And we can do the long division.
With pleasure. Okay. Oh, you're done with all of them, Yandi, all the way down to the bottom. Okay, you're just going to have to give me, okay, Theo, just give me 2 seconds. I'm just going to help Tamisha with the long division.
No problem, ma'am.
All right, thank you very much. Okay, so now, Tamisha, what we're trying to do here is we are trying to divide 7 by 8. That's what it means. Okay, so this is 7 whole units. So our decimal comma belongs here, and we've got to remember, we've got to write things in columns. And we would say to ourselves, does 8 go into 7? And the answer to that is no, 8 doesn't go into 7. So I'm going to need to add another 0 over here. Then I'm going to say to myself, how many times does 8 go into 70? How many times will it be, to me, show? Eight times 8 is
64.
indeed. Okay. 8 times 9 is
72.
okay. So that's exactly, well done. So that's going to be too big, isn't it? So I'm going to have to say that it goes in 8 times. So 8 times 8 is 64. So minus 64. Draw a line underneath. 70 minus 64 leaves me with 6 left over. Now I can add in another 0 and I can bring my 0 down. Okay. How many times does 8 go into 60? So 8 times 8 was 64. So it's got to be smaller than 8. 8 times 7 is? 8 times 7 is?
54.
56.
Oh.
56? Okay, so 7 times 8 is? Oh, is it 54? No. 9 times 6 is 54. 7 times 8 is 56. Okay. Sorry, it's late in the evening. We all end up making mistakes, don't we? Okay, so now 60 minus 56 leaves us with a leftover of 4. So now, because there's that third decimal place, we're going to need to add another 0, bring that all the way down over here. And now finally, how many times does 8 go into 40? It goes in there 5 times. 5 times 8 is 40. And when we take 40 away from itself, we are left with 0. So that's where we get the 0,875. So I think it's up to you. You must do whatever your teacher suggests you do at your school, but both methods are perfectly acceptable, whichever one you think is a little bit faster. I think probably working with the fraction is a bit faster, but if you want to do long division, there's nothing wrong with that. Okay, so now are the rest of you finished? Who else is finished? I know.
Ma'am, I'm finished.
You finished, Trevor. Okay. All right. So Trevor, I would... You also done. Okay. Thank you, Yandi. Okay. So Trevor, what did you get 0,875 as a percentage? How would we write that as a percentage?
Ma'am would say 87.5%.
Indeed, we certainly would. Well done. Perfect. Okay, Pumzile, what did you get for a quarter as a decimal? How did you write that as a decimal?
Ma'am, can I try?
Okay, Yandi, go for it.
As a decimal, ma'am.
Yes, as a decimal.
0.25.
0,25. Good job. And Pumzile, do you want to tell me what that is as a percentage?
25%.
25%. Good. Well done. That's great. Grade 7's excellent work. All right. So we're nearly there. Let's see who I haven't given a chance to chat or to say anything just yet.
Can I go?
Who's that wants to have a go?
No.
Anel. Okay, Anel.
Anala.
Okay, so what I did was times this 10 times the 10 by 10 and the 7 by 10 to get 70
Okay.
over 10.
Okay, so
And
you
then-
times that by 10 and that by 10. Okay.
And then I got 0.7 as a decimal and 70% as a percentage.
Indeed, 100%. Well done. Okay. So in fact, with this one, you didn't even need to times by anything because it was already out of 10. Okay, so if it's already out of 10 or 100 or 1,000, then you don't need to multiply it. So in the same way, 3 out of 10, all right, would end up being 0, 3 indeed, and that would end up being
30%.
30%.
30%, just like that. Okay, are there any questions?
Ma'am,
Yes, Jethro.
ma'am, let's say you have a fraction, ma'am.
Mhm.
What the numerator is smaller than the denominator, ma'am. How does it
Yes.
not change into a negative number?
Okay, that's a very good question. All right, so let's pretend we've got something like this. We've got 1 over 2, or I've got 1 over 5. Or if I could imagine I've got something really, really tiny, I've got 1 over 80. All of these lie on, I have a place on the number line. So your number line actually has 0 in the middle. And all the positive numbers are to the right-hand side of 0. So if I'm going to put 1 over here, then 2 would be somewhere down here. And if I continue going in that direction, numbers would get bigger and bigger. And if I turned around and I went in the other direction like that, then numbers would end up getting smaller. Okay, so there's -1. So it's only once I get past this point over here, once I get past 0, then numbers become negative, right? So with all of these fractions that I've got on the screen right now, 1 out of 2 is a half, all right? So in other words, it's halfway in between 0 and 1. So it sits over here. So that's not on the negative side. 1/5 means now, instead of me cutting this piece from here, from 0 to 1, instead of me cutting it in half, now I'm cutting it into 5 equal pieces. So if I come along, let me just get rid of that one over there. Oh, I didn't mean to get rid of the blue line. Now if I cut it into 5 equal pieces, 1, 2, 3, 4, 5. Over here, that's where 1/5 would be. Over here, this is where 2/5 would be. Over here, this is where 3/5 would be. Over there, that's where 4/5 would be. If I got to 1, then that's where 5/5 would be, because 5 divided by itself is 1. So all of these are still bigger than 0. That's why they're not negatives. Okay, so if you've got half a piece of pizza left, it's still bigger than 0 pizza. Okay, so numbers only become negative once we move past 0. Okay, so once we get past this point over here, that's when numbers can become 0. So some examples for us of where numbers would become 0 is like with temperature. So in places where it gets really, oh, that is a terrible line that I've just drawn. My apologies. Okay, 7s. Let's see if I can draw something a little bit better than that. Being so squiggly tonight. Okay, so in some places in South Africa, it gets really, really cold. All right, so it gets down to 0 degrees. All right. And then if it gets really, really cold in winter, for example, like in Johannesburg or in Bloemfontein or any other sort of Pretoria inside of the country, then the temperatures become negative. So if I go 1 below, then I would get to -1. If I go 1 below that, I'm going to get to -2. If I go 1 below that, I'm going to get to -3 degrees. Exactly. Okay, so what I've drawn here is a number line. Okay, it just happens to be vertical. Here I've drawn a number line. It just happens to be horizontal. So because all of these numbers are bigger than 0, that's why they don't have negatives in front. Okay, so you've got to go past 0. Okay, so below 0 or to the left. Yes, Yandi.
Ma'am, can I ask, ma'am? So, ma'am, let's say you give us like let's take it for example 1 over 80 plus 1 over 5 divided by 1 over 2, and you say that we should find the decimal and the percentage of those sums.
Oh wow, that's a difficult question. Is this correct? What I've just written down, what you've said over here, is that what you're asking? So 1/80 plus 1/5 divided by 1/2. What are you asking what you would do then?
Yes, ma'am.
Okay, so you've got to remember BODMAS. All right, so BODMAS tells us that we have to do dividing before we do adding. So what you would have to do for this sum over here is keep the 1/80 like it is. Then you would have to apply your rule for dividing fractions, which if you remember our keep, flip, change, or tip and times, we would keep 1/5 as it is. We would change the sign from divide to times. We'd put 2 at the top and we'd put 1 at the bottom. Then we need to remember how to multiply fractions. So we would say 1 times 2 is 2. Over 5 times 1 is 5. And now, last step, we've got to divide first or multiply first and then add, because adding comes after multiplying and dividing. Now I need a lowest common denominator. Okay, so what I would do here is 5 goes into 80 if I multiply it by 16. What I do to the bottom, I've got to do to the top. And now I'm going to end up with 1 out of 80 plus 32 out of 80. And that's going to give me a final answer of
33/80.
Indeed.
Ma'am,
Yes, Njabulo.
ma'am, does every number have to be divided by or long isn't divided by 1,000, or can it be 100, tens, or?
It could be, it just depends where we're sitting as far as the numbers are concerned. Okay, so if I've got, but it will give me different answers. So let's say I've got 7 divided by 10. And then over here, I've got 7 divided by 100. And then over here, I've got 7 divided by 1,000. These are all different. Okay, they all have different values, right? The divided by 100 and divided by 1,000, it's getting smaller and smaller. Okay, because this means 7 out of 10 pieces. This means 7 out of 100. This means 7 out of 1,000. Okay, so your fractions are getting smaller. So if you've got 7 out of 10, that's 0,7. Your 7 is sitting in your tenths column. But if you've got 7 out of 100, then you've got 0,07.
7.
Exactly, because now your 7 is sitting in the 100 column. Exactly.
So,
Right,
ma'am, what about the 1,000?
Good question. So now it's going to be 0,007. Like that.
Ma'am, does
Because
it go
now
up
your
to 1 million?
do you know what? It never stops. It never ever stops. So you can
Infinitive.
keep dividing, and numbers, this is
Infinite.
the craziest thing, is that numbers can keep getting smaller and smaller and smaller and smaller and actually never ever get to 0, because it can just keep being a smaller fraction and a smaller fraction and a smaller fraction. So that's one of the really weird things about numbers, because we could take 7 and we could divide it by 1 with lots and lots and lots and lots of zeros afterwards. But then somebody else could come along and they could take 7 and they can divide. Here we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 zeros. Well, we could make it 11 zeros.
Ma'am?
11. Okay, so they would just keep getting smaller and smaller. Yes.
Ma'am, the example that Yandi made, ma'am. Ma'am, can you, ma'am, why do you change the operator from division to multiplication?
That's fine. Do you remember we had, I think it was our 3rd lesson, we spoke about how we divide fractions. And when we divide fractions, we always have to do that. We always have to do tip and times. Okay, so if I give you 2/5 divided by 3/10, you have to keep. So that's why we've got that rule: keep, flip, switch, or KFC. Oh, what's K? Sorry, it's been a long day.
SFC,
KFC.
ma'am.
Yes, KFC, quite right. Okay, so keep, flip, change, or keep, flip, switch. So we've got to
Ma'am?
keep the first fraction the same. Yes, is that you, Njabulo?
Yes, ma'am. Why can't you just divide it?
You are not allowed to divide that. Do you know?
Because-
Denominator.
Yeah, because you see, dividing fractions is not something that actually exists, to be honest with you. And from there, it sort of starts to get sort of quite technical. But what human beings have worked out is that if you, let's just take another example. Let's say if you take 6. If you take 6 things and you divide each one in half, how many? So let's say you've got 6 pieces of chocolate, all right? So if you take each piece of chocolate and you divide it in half, how many pieces of chocolate have you got now? You'll have 12, okay? Because you had 6 to start off with. So if I draw 6 blocks here, so 1, 2, 3, 4, 5, 6. If I come along now and I cut each one in half, where I had 1 block of chocolate, now I've got 2. Where I had 2 blocks of chocolate, I've now got 4. Where I had 3 blocks of chocolate, I've now got 6. And so onwards and so onwards. So if I keep cutting them in half,
It's odd and even numbers, right?
it's odd and even numbers. That's right. Okay, but now we're talking about how many blocks of chocolate I've got if I break each one in half. So what human beings have figured out is that if you keep the first number the same and you change the sign to its opposite and you put what was at the top at the bottom and what was at the bottom at the top, you end up with the same answer. All right, and that's where it comes from. So that's just become a rule that we use. So if we're going 2/5 divided by 3/10, we have to write it as a multiplication. That's the rule. We have to change the divide to a times. We're going to put the 10 at the top. We're going to put the 3 at the bottom. And then, Jabulo, you can do one of 2 things. Either you can cancel down first, or you can multiply first and then cancel down. If you multiply first, you have to say 2 times 10 is 20. 5 times 3 is 15. But you're not allowed to leave your answer like that because both of these can be divided by 5. 5 goes in here. 3 times 5 goes in here. 4 times. Now, when you get to high school, they'll allow you to leave your answer as 4/3. I don't know if they let you do that in primary school. So the only other way that you could do it, if you didn't want to do it like that, your other option is to do this. You would say 5 goes into itself once. It goes into 10 2 times. Again, when you multiply fractions, multiply numerator with numerator. 2 times 2 is 4. Denominator with denominator. 1 times 3 is 3. Okay, that's where it would come from. Shame, we've actually gone a little bit over time here. I'm sorry, grade 7s. I just carry on talking and talking and talking. I hope you're feeling confident with that. It's a good thing that you actually asked this question today, Yandi, because our next lesson, grade 7s, is going to be a quiz, and it's going to be a quiz on everything that we've covered in this course so far. So it's going to cover equivalent fractions. It's going to cover multiplying and dividing, adding and subtracting, and a little bit of fractions, decimals, and percentages as well. But it's going to be in the form of a multiple choice. So you've got to make sure that you've got your book and your calculator and your pens with you. And then you guys are going to do the test, and then we're going to mark it afterwards, and we're just going to see how we're doing. Hopefully we've been able to make some progress. Okay. I'm going to hand you back to Elzon now.
Okay. Hey. Ma'am, can I ask before you go, ma'am, when is the quiz?
On Thursday.
Thursday.
Yes, on Thursday. Yes, because that's our last time together. Then we finish with fractions.
Ma'am, how do you pronounce your name?
It's Lee.
Oh, Lee. I've been saying Lehung.
It's all right. Don't worry. Don't worry. You would say lay, because I mean, if you think about it, like Santa Claus rides in a sleigh. So English is silly like that, isn't it? We say that is sleigh, and then my name is Lee. So
Sleigh Queen.
Lee, thank you so much.
thanks, Elton.
Okay. Hey guys, I hope you're all well. You also look very happy and not tired at all.
Ma'am, some of us are tired, ma'am.
Are some of you tired? Oh, well done for staying on for the whole hour. You guys are showing a lot of grit.
So 7 o'clock, I should be sleeping now. You.
So guys, I just want to show you that you guys have done 5 lessons already. Today you guys did fractions, decimals, and percentages. So as Lee said, there's only one more lesson left, and that is the quiz, which is on this coming Thursday.
Yeah.
So I hope that you all will prepare before then. The fact
fractions, dividing fractions, adding and subtracting fractions, fractions, decimal, and percentage.
who's sharing with their parents on fractions?
Ma'am,
Lee,
somebody take a rest, ma'am.
Lee, you're doing a good job. They're not keeping this information for themselves.
That's good. I'm so pleased to hear that.
Okay, guys. So, like Lee said, Thursday is quiz night. So then we'll get to apply all our wisdom and all the work that we've learned in this quiz. I hope you guys are ready. If you're not, there's still time, so don't worry. And then before then, if you want to get a bit of revision in before the quiz, you can just go to your Watobi app, as you all know, into common fractions. And then the revision work for today is under percentages, and it's called fraction, decimal, and percent. Okay. I hope that you guys had a good day, and we are all looking forward to seeing you again on Thursday. Till then, take care of yourselves and study hard, hey? We
Yes,
are proud
ma'am.
of you guys.
Okay. Bye,
Yes, ma'am.
everybody.
Bye, ma'am.
Bye-bye.
See you on
Bye,
Thursday.
Bye, ma'am.
Bye.
ma'am.
Bye,
Bye.
ma'am.
Bye.
Bye.
Bye,
Bye, ma'am.
Well done. Bye.